So yeah, I'm going to try and do something special. One thing I'm going to do, though, is I'm going to try and spend a little bit more time with my dogs. I haven't had much time with them lately, so I'm going to take at least part of my day and just do something that they consider fun, you know, like take them down to the pond or something like that. So I've been wanting to do that, and I think it'll make me feel better. I notice whenever I do something for somebody else, that's what makes me feel the absolute best. So, okay, so what we're going to do is we're going to do the back of this. If you were gone yesterday, you need one of these. Okay? Oh, and it fell down. Dang it. Okay. So I want to do these back too. Okay? And then we'll talk about the front. Okay? Okay. And you'll see, hopefully, after we get going, why I'm doing it in this order. Okay? So find G composed with F. So we're going to take the F result and put it into G. We're going to take the G result and put it into F. Those are two different things. So let's do both of these, and I want to make sure that we can do this well, because this is going to be an important skill. Calculus would not be possible without the skill that we're going to teach right now. And I know some of you guys may not be interested in calculus, but I'm just showing you why it's an important skill for us. Okay. So G composed with F. I prefer to think, okay, that right there is going to be G and then F of X. So to do this in general, in terms of X, well, yesterday we took 2 and put it into function F and took that and put it into function G. Remember that? Okay. Well, here we had a specific number that I could calculate in F, and then I could calculate that into G. Now we need to make a rule that is going to give us G of F of X all the time for all values of X. So what am I going to do? What am I going to do with this F of X? Plug it into G. So I'm going to take this whole thing and I'm going to plug that in for G. So the G function is the negative 4 times blah minus 5 function. That's how you have to look at this. Whatever I put in, I'm going to take times negative 4, and then I'm going to subtract 5. That's what the G function does. It takes negative 4 times whatever and then subtracts 5. Well, the whatever in this case is my other function.
Can we put the f of g, like you do the opposite first? Put the f into the g?
That's what we're doing right now. Well, we could do either one, but this one right here, I'm doing this one because it's the easier of the two. Okay? So this one I'm going to take f, put it into g because that's what it's asking us to do. I'm going to take f of x and put it into g. So then I've got plus 3x plus 1. And then I just simplify. I'm going to negative 8x squared minus 12x minus 4 minus 5. So negative 8x squared minus 12x minus 9. Okay. Do you guys have written down what we found for g of f of 2 yesterday?
Negative 65.
For the first one. Yes.
The final thing was negative 65.
Negative 65 on this one? Negative 65 is what we did yesterday. Let's see if I'm just okay. I'm just going to do this for my own personal Okay. So here's what I just showed. Our old-fashioned method yesterday of taking f of 2 and then plugging that into g gave us the result. But if I take this 2 and plug it into this complicated function now, we do get the same thing. So that's a way to double check and make sure I'm right. Hello. Arrived and keep. Okay. Okay. So I didn't mean that to confuse anybody, but I was just, for my own personal satisfaction, I was trying to make sure I was correct. Okay. So now, Zach, you were asking to do the other way?
Yeah. Will we get the same answer or no?
No.
Okay. That is
Nope.
the other way, so I was just curious.
Okay. Let me address, will you get the same answer? Okay. So what he's asking is if I do two different things to something and change the order, will I get the same thing? Okay. Let me think of a real life example. I can't think of right off the top of my head. Okay, that's kind of a naughty example. Okay, here we go. You're just getting out of the shower after a football practice. Okay, you're going to do two things. You're going to run through the gym, and you're going to put on your clothes. Does the order of operations make a difference?
No.
Yes.
Putting on your,
Yes. So the end result of one of them is people wonder, why was he running through the gym? The other end result of the other one is, why was he running through the gym with no clothes on? Okay? So yes, if you do one thing and then another, your end result might be totally different. Okay? So in this case, order of composition does make a big difference. Okay? And I'm sure if I had more time, I could find an example that was a little bit better. Okay? Okay, so f composed with g of x, but I do appreciate your question, your query about will it give me the same thing.
Don't we need to find both of them though?
We are. Yep, so that's what I'm doing right now. Okay? So find f, g composed with f, and f composed with g. So this one, f composed with g, I'm going to do g first, and then I'm going to take that result and put it into function f. So look at how this one's going to end up. Function f is the 2 times burnt squared plus 3 times burnt plus 1. But what am I going to put in those blanks? Negative 4x minus 5. Okay. So now I've got to multiply that out. You guys are like, yay! So excited about multiplying that. I'm going to do a little trick, though. You guys interested in seeing a little trick? I'm going to go ahead and multiply this one through. Nah, I'll leave it. Why can I do that? Why are those two things the same? What did I take out of here? The negative. And what's going to happen to my negative when I square it? It's going to go away. So I use my intuition to say, okay, it's going to disappear anyway. Okay? So let's do this. I might ask you guys to do this. 4x plus 5. 4x plus 5. Now this, to me, is kind of the boring part, but it's a skill that I want to make sure you guys can do. Okay, let's just multiply these two together first. $16x squared plus what? What's my middle term going to be? 40. Nice job. Because I get 20 and another 20 gives me 40x plus 25. And then the rest is just kind of child's play from there. But I'll finish it. What the heck? And I don't know, not one of my favorite problems because at the end we just get something that really doesn't mean anything to us. But you can see that it is drastically different from the other one. Okay, but this process is going to help us with the other side. Trust me. We will work on this particular concept a little later, but this is what's called the difference quotient. Okay? This is, we've done this so many times in calculus so far, but now we don't need to anymore. We found a shortcut. You know what? Don't draw this, but I want to explain it. I want to explain where this is coming from. Okay? If I have some function, this is x, and this is some value h, what would this value right here be? I started at x and I went h units over. So what's this? X plus h. Good. Okay. This value right here is f of x. This value right here is f